Welcome everyone to lecture 3 of our course on astronomical data analysis using Python. At the beginning of my previous lecture, I showed you this program, which is our first program that we wrote in Python. So this is just reproduced here for your convenience. And what we did was we set a bunch of variables and then we did some computations using those variables. And then we printed the results of those computations. Now we are going to take this program and modify it in the following ways. We are going to rewrite it so that we use floats instead of ints. We will accept the numbers from the user instead of hard coding those numbers, right? So the modified program is given here. You can basically see that the first two lines have changed. We have A is equal to input, please enter number 1. So what that function input does is that it puts up a prompt, whatever is the argument, in this case, please enter number 1, will appear as a prompt, and then it waits for keyboard input. And whatever is typed out on the keyboard gets stored into the variable A. Then it asks you for the second number B and stores that similarly into the variable B. And then you do some calculations. We'll come to that in a minute. But if you run this program, you will find that the program crashes. It stops. So in Python, one of the advantages is that being an interpreted language, you know exactly which line there is a problem, right? And you also tries to be very helpful and tries to guess at what the problem could be. So here it tells you in that red font that this is a type error. Okay? And on the last line, it gives you some more helpful information. It tells you that there are unsupported operand types for str and str. Str means strings. So what is happening is you're trying to add two strings, a plus b, and trying to subtract two strings, a minus b, and so on. Obviously, for strings, these methods, such kind of methods, are not allowed. And therefore, the program crashed. So what do we need to do? What is the problem? Let us look at it a bit more carefully. Anything that is input through the keyboard, whether you type in a number or you type in a set of characters or a phrase or a sentence or whatever it is, it appears or is stored in a variable in the form of a string. And because strings support addition, which is the concatenation operator that we saw last time, but very little else, you run into trouble because you're trying to multiply two strings or divide two strings and so on. And then you run into real trouble. So what should we do? Remember when I typed in the number 3 on the previous slide here, right? Python read it as a string. And then it tried to add it to the string 5, which worked. But moment I tried to subtract it from the string, I mean, subtract 5 from the string 3, the string 5, it crashed. So one has to convert this number 3.0 into a float. And in order to do that, we use a simple function, which is called float. And you give it a single argument, which is the object of some other type, which is not a float. You want to convert it into a float. Suppose by mistake you already have a float. That doesn't matter. It then just returns the same number. So let us now rewrite our program to convert the inputs that we read from the keyboard into strings. So here it is, and the changes that have occurred in the program are over here and over here. We've added this extra typecasting, as it is called, to convert the string inputs that we are reading directly into floats and storing them into the variables A and B. Notice that we are nesting functions here. I showed you some nested functions in the previous class. So that is exactly what's happening. You read the input, and whatever is read into the input, which is a string, gets directly converted into a float type object, and that gets assigned to the variable A. And similarly for variable B. And now the code will run. We have C comma D equals to A plus B comma A minus B. So the sum and the differences get assigned to C and D. And then Q is the quotient, A divided by B. And I is something new. What is that? That's an operator that we did not mention the last time. And that operator is called the floor division operator. Let us run the code and see what the outputs are. So again, I entered number 1 as 3. I entered number 2 as 5. And the addition, of course, of these numbers is 8. The difference is -2. The quotient is 0.6. And the floor division quotient is 0. Notice here that unlike the last time when we were working with integers, now we are working with floats, but the output looks pretty ugly. Is there some way in which we could control the number of decimal places that are printed out? And if we do that, we can do that, it turns out. And the way to do that is to introduce some kind of additional text into the code, which is I'm highlighting here, %.2f. And similarly, difference equal to %.2f. And outside you put a percentage sign and you put the variables that you want to actually print in those two locations in the right order. So the addition is stored in variable C, the subtraction or the difference is stored in variable D. Therefore, you have C comma D over there. And similarly, you have modified the next line where you print the quotient and the floor division quotient. And as you can see now, the outputs look very nice. We just have two characters or 2 digits after the decimal place. And it looks much better than what we were seeing earlier. So what we have seen here is a powerful way of constructing strings in the previous example. So what do we have? We had a line like print addition equals percentage dot 0.2f and so on. And what does it do? It basically instructs Python. This is a formatting instruction. Those of you who have used C or Fortran or some other C-like language will immediately understand this way of string construction. The instruction there is that I want 2 digits after the decimal point, and the variable that I'm going to supply is a float. That's why the F. And that's why it prints 8.00 and -2.00 in the output. Python supports this C-like way of formatting strings, but it also has its own ways of string formatting. Let's look at that for a moment. So suppose you have some galaxy name NGC 7709 and it has some integrated B magnitude. We can construct a statement 1 which basically says that the galaxy percentage S, now S indicates that that variable is a string, has an integrated B band magnitude, of whatever, that number 13.6. And we've specified what format to use for the string and for the floating point number, which is the integrated B magnitude. Statement 2 is slightly different. It is one of Python's unique ways of specifying the format for a string. And here we've put in braces 0:s, and here within braces 1:0.2f. This 0 refers to the the number of the variable that is going to be supplied. So for example, here gal name is of course the 0th or the first object, 0 numbered variable that's applied in this argument to the format function, and 1 is of course the second argument. And so if I swap these, the order of gal name and int b magnitude here, I would also need to swap it here. I could put 1 here and 0 here, right? And then it would print correctly. The third statement is again a sort of equivalent name, wherein you use some kind of labels for the variables. Okay, so for example, I use the label name here and mag here for the label, and in the format function I say name is equal to gal name and magnitude is equal to integrated b magnitude. So I supply the names of the variables that are associated with the labels name and mag, which I've used in my format string. All of the above statements are equivalent, and we can prove that by just printing statement 1 followed by statement 2 followed by statement 3, and you see that they all print out the same thing. You can choose whichever method you like best. As a former C++ user, I tend to use the first method if I want to print some values in my programs. But the second and third methods are more Pythonic. If you don't have previous experience with the C-type formatting, I would suggest that you go with one or more of the Pythonic ways. Now let us look at one more thing in string formatting, which is the idea that Python has of raw strings. We have seen 3 methods of string declaration previously. We've also seen string formatting. String formatting taught us that symbols like brace or percentage have special meanings within a Python string. But suppose we want to print those special symbols like percent and brace as part of the string itself. How do you do it? You can ask Python to ignore all of those special symbols simply by putting a letter R in front of the string. Okay, so here is a percentage sign, percent, and a brace. But because I have the string R, Python knows that this string is to be interpreted as a raw string, which means it should not try to interpret what percentage and brace stand for in the usual Pythonic way, and it just prints it like literally as it is. And we get here as the output, here is a percentage sign, and a brace, closing brace there. So this works. Why is this useful? It's useful because whenever we make plots and set labels, we would typically like to invoke a LaTeX parser. And those of you who have used math mode in LaTeX know that there will be lots of backslashes and dollar signs and curly braces in there. In such cases, it's best to use raw strings. So for example, here there is a sample of code which we will encounter in a few weeks. So that is basically a X label. That's the label of the X axis. And that is given as a raw string log \rm. Those who know LaTeX will know this is in the Roman font, and underscore meaning subscript V. And because of that little r which is sitting here, the string will be interpreted not by Python itself, but will be interpreted by the LaTeX parser, and the output will come out the way you want it. Of course, there are other situations where special characters appear, like Windows file paths, HTML code, XML code, etc., etc. If you ever need to print those strings, then you should probably use the raw string option. Let us now move to a different topic, and that is the topic of conditionals. Conditionals are there in every major computing language, and they basically tell you what to do if a certain condition is satisfied and what to do if it is not satisfied. So we have a simple code snippet here, num, which stands for a number. It asks the user to input a number, and that is typecast now into an integer. So just like we had the float function, which converted its argument into a float, there is this int function, which converts its argument, in this case, the number entered on the keyboard, into an integer. And then we have our code. It says, if num %2 equal to 0. So what does num %2 mean? It means you divide it by 2 and get the remainder. If the remainder of the division of num by 2 is 0, then you print %d is even. So what is d indicating? %d is a way of indicating that you want to print an integer. Else, and then there is another block, %d is odd. So if I run this code and it'll ask me to enter a number, I entered 3, and of course it printed 3 is odd. So this is, those of you again who are familiar with Fortran or C or Java, etc., will recognize the structure of this conditional. It's called the if-else conditional. So if some condition is true, you execute some block of code. If that condition is false, you execute some other block of code. And this is exactly what this 5-line program is doing for us. You will use conditionals a lot in your data analysis, and therefore you may have a more realistic program which may look at this. So what I do is, suppose you want to fit different models to your data. So what you do here in this piece of code is model choice is equal to int input enter choice 1 or 2. So here I'm assuming that there is either model 1 or model 2 that you want to run on your fit to your data, right? Now, model choice. So you ask the user, which one do you want to run, model 1 or 2? Enter your choice, 1 or 2. So if the model choice equals 1, then something is done. That model 1 of spectrum 3, of object 3, spectrum equal to 3, but it may be a whole array, or it may be a spectrum of object number 3 in your sample. Whatever it is, I've of course commented that out because that function has not been coded here, and the program will give an error if I uncomment that line. But in your real code, that would be uncommented. And in the end, it would print model 1 is fitted. Now you have one more structure which has appeared in between the if and the else, and that is the else if structure, which is which in Python appears as elif, E-L-I-F, which is short for else if. So elif model choice equal to 2, it will then fit model 2 spectrum and print model 2 has been fitted. Else, so if you enter instead of 1 or 2, you enter 3 or 5 or -100 or whatever, it will print invalid model entered. So again, I've run this program and it asked me what's your choice? I entered 2, and then it printed model 2 has been fitted. So these kind of conditionals are very, very common in real life situations. I would like to mention here that you can have multiple else if statements. So you check if something is valid. If not, that condition is some other condition valid, or is some third condition valid, and so on. You can have any number of elif statements in this block, just like you can have any number of else ifs in your Fortran program. And then eventually, if none of those conditions are valid, whatever is there in the else block will be executed. So what do you notice apart from the syntax in the above example? We have encountered the syntax. The key thing to remember about the syntax is at the end of the if statement or the else statement and so on, there has to be a colon. If you miss the colon, then Python will give you an error. Remember that as part of your syntax. But the other thing to notice is that there was indentation. Okay, so let's go back to the code and notice that these two lines, which are part of the if block, are indented to the right. And similarly for the elif block and the else block. We do not have any braces or any other way of identifying to Python that this block of code is part of the if block and should be executed if the if condition is satisfied. The only way we have done it is via this indentation. This is one of the unique things about the Python language. Indentation is at the heart of Python's way of delimiting blocks. Python has only indentation as a way of delimiting blocks. It does not allow you to put braces or any other symbol to identify the blocks in your program. Function definitions, loops, if blocks, nothing has your typical boundaries like the curly braces that you see in C and C-like languages. The level of the indentation is the only way to define the scope of a block. So if you look at the following C-like code, so if x greater than 0, if y greater than 0, print something, else print something. Which if does the else belong to? There are two ifs there, right? In C and C-like languages, you would have to use braces to indicate which block which if the else corresponds to. In Python, an indentation, if you have it, is purely optional. You can have wrong indentation in C also, it doesn't matter. In Python, indentation levels determine the scopes. So for a code like this, if you wrote it in Python, of course, remember this is like pseudo code. It isn't even correct C code. It's pseudo code. So, but just to give you a feel for the indentation structure. In Python, the else belongs to the if x greater than 0 if, not to the if y greater than 0 if. And that is because it's absolutely clear from the indentation. The else has no indentation and therefore it belongs to that outermost if block. Python therefore forces you to write very clean code. And if you're fond of obfuscation, you can go and take a jump, is what Python says. While putting in the indentation, you can use either spaces or tabs. Don't ever mix them. You decide once and for all, I want to use a tab or I want to use spaces. I'll come in a moment why spaces are better, but whatever you choose, just use them consistently. I personally use 4 spaces for each level of indentation, and I have configured my IDE, my development environment, so that whenever I press tab, it puts in 4 spaces instead of putting a tab, of course, only within a Python program. So I recommend you to do the same. Tabs sometimes are problematic because across operating systems and sometimes across editors, A tab can put you forward by 4 spaces, or it can put you forward by 8 spaces or 6 spaces and so on. So it things can get misaligned, but whatever you do, you can use spaces, you can use tabs if you really want to, but please don't mix them. Your programs will crash in horrible, horrible ways. Okay. So what is the structure of the general if, else statement? If some condition is satisfied, there is a colon there, remember, then there is a if block which says do this and this. And then there could be any number of elif blocks where if any of the elif conditions is satisfied, that code gets run, and then the program exists out of the else if block. If none of the conditions are satisfied for this if elif else block, then finally whatever is there in the else block will get run, right? So it is guaranteed here that one and only one out of the blocks, the if block or one of the elif blocks or the else block, will get executed in your code. Okay, so what are these conditions? The conditions are anything that return true or false, and we'll look at those in a minute using real examples. These are the operators that are used to, these are the conditional comparison operators, equal to, okay, for checking if two objects are equal or two sides of the equation are equal. Not equal to, greater than equal to, less than, and less than equal to. You can combine multiple conditionals using logical operators, and these are and, or, and, not. So let's look at some examples. And here we encounter for the first time a new data type, which is the Boolean data type. Very important data type in Python. You'll use it very frequently in your data analysis, particularly when you are using it to, for example, to mask certain regions of your data. You could set a flag or make a map file, mask file, which identifies bad data in your data set. So we have now defined a variable a equals true, b equals false. True and false are reserved keywords in Python. They are the values of the Boolean variables. So if A, print this comes on screen, and if B, this won't come on screen. If A or B, print this also comes on screen, and if A and B, print this won't come on screen either. So you run this program and only 2 lines, this comes on screen and this also comes on screen, will get printed. And this illustrates for you clearly what is happening. In the if block, a conditional, the condition is evaluated. So if A, so does A evaluate to true? It obviously does, because it's a Boolean variable with a value of true. And B evaluates to false, so that if block doesn't get executed. If A or B, what does that mean? It means that if either A is true or B is true. In our case, A is true. Or B is true, return true. So in our case, A is true, so A or B is also true. And similarly, A and B, because if both are true, that the next line would get printed. In our case, one is true and the B is false. Therefore, it doesn't get printed. If you now you encounter a new function, a new built-in function, which is also very useful to check the type of an object. So if you type type and in bracket the name of some object, it tells you the data type of that object. And obviously that's a Boolean. Almost all other types have a sort of Boolean equivalent. So again, here, those of you who know C would understand this very easily. But if A is an integer here, And if it's an integer with a value of 1, that evaluates to true. And if it's has a value of 0, it evaluates to false. In fact, I think if it's any other integer, it evaluates to true. Only 0 evaluates to false. So now in this code block, only hello will get printed, oh no will not get printed. And the type of A, of course, is just an integer. Even in a string, you can put it into as a conditional of a if block. S is equal to empty, S1 is equal to an empty string, and S2 is equal to the string hello. If S1 print won't be printed, and if S2 print will be printed, and of course the will be printed line prints, because that S1 in that context of the if block evaluates to false. And because it evaluates to false because it's an empty string. If it were a non-empty string, any characters including space, it would evaluate to true. And then it would get printed. But since it's a blank, an empty string, it doesn't get printed. This is bad Python style, because remember, explicit is better than implicit. Okay, the code should be clear. It should not be implicit that if it's 0, it means false, and if it's 1, it means true, and so on. These are just numbers. They're not the Boolean values to true or false. So it is expected that, or it is preferred that you use an expression that evaluates to a true Boolean, and keep your programs readable. Now we'll look at some other conditionals. So if 5 greater than 6, obviously that's not true. X is equal to 2, else X is equal to 3. So X will get set to 3 in this code block. Then we set Y equal to 2 if 5 greater than 6, else 3. So this is a shorthand way of writing a if-else block in just a single line. It basically says that if 5 is greater than 6, then set Y to 2, otherwise set Y to 3. And of course, Y will get set to 3 in this case. So if you do print X comma Y, it's going to print the value 3 for both X and Y. We are now going to take a second plunge into the data types, and we are going to look at the other data types that we need to do, that we need to know. We are going to look at 2 data types, lists and dictionaries. And there are some other data types that I will not cover in any great detail in a formal way. They will appear from time to time. I will just tell you enough for you to move forward. These are tuples or immutable lists. Then sets, which are what are called keyless dictionaries. So we're going to do the regular lists and the regular dictionaries, not tuples and sets. We are going to not look at complex numbers. You may think that complex numbers appear frequently in data analysis. In radio astronomy, for example, they're used to represent the amplitude and the phase of an electromagnetic wave. But in actual code, they usually appear as a tuple, a pair of 2 numbers, one which represents the coefficient of the real part and the other of the imaginary part. So they usually appear in your code as 2 numbers. That's because some of the early programming languages did not support a complex number data type. But it exists, a full-featured complex number class exists in Python. The data type exists. You can go and look up the documentation. I'm also not going to talk about fractions and decimals because we don't use them too often in the data analysis. Let us now begin to look at lists. So what is a list? A list is a simple ordered collection. So I said A is equal to now square brackets. Notice the square brackets have appeared. 1, 2, 3, 4, right? And then I set create another list B, which I set equal to something else. Notice here that unlike arrays in other languages like Fortran and C, which are of the same type, so these are not arrays really, right? Because in a Fortran array or a C array, you could have a float array or an integer array or whatever. You couldn't mix strings and integers and floats and booleans together like we have done in this line. Okay, but Python list happily accepts this combination. All the sequence operations that we learned in the previous class are valid for operations on lists. So A0 refers to the first element of the list A, which is 1. A minus 1 refers to the last element of A. A1:3 refers to the two elements starting with A1, which is the second element, because remember we are 0 indexed in Python, and going up to every element except the A3 element. So this is going to print out for you the element A1 and A2, which in this case is 2 and 3. That's what gets printed on the next line. You can also index the list into a deeper structure within the list. So what I mean by that is, suppose you do B0. B0 will obviously be the string hello. And then you put another square bracket and I put 1. That will give me the second element or the second member of the first member of the list. So it's going to print out the character E for me in this case. If I had done B02, it would have printed L and so on. This is allowed. You can construct lists of lists. So the A is a list of lists because it's a list which contains as its members 3 lists: A, 4506, 789. Okay. You can access those elements via these nested structures. So A21 refers to element 2 of the lists themselves. So which means this is 0, this is 1, this is 2. And within A2, I go to the second element because I've again 0 indexing. So this 1 corresponds to the second element. And that's why this A21 gives me an output of 8. Concatenation of lists is allowed via now the list concatenation operator plus that is supported. Even repetition, like we saw in strings, is allowed. So you can make a list 168*3 and it'll create a longer list where the elements of this list will be repeated 3 times. Lists are mutable. Unlike strings, the lists are mutable, which means they can be changed. So I've defined a list here within square brackets. I print the list, it's fine. And then A2, which means the third element of the list, is set to 777. If I print A, it has now taken this list and replaced that third element with 777 over here. So unlike strings where you could not change the elements of that string, lists are mutable. List methods are there. So just like, see, remember, list is also an object. In Python, we saw that there's an integer, which is an object, and every float is an object, and so on. Similarly, every list is an object. So it will have its own associated properties and its own associated methods. So we've defined A, we've printed it out. There is a method called append, which adds an element to the end of your list. So now I got 1, 3, 5 and the element 7 got appended to it. There is also an extend method which concatenates a list at the end of your list A. So I had this 1, 3, 5, 7 to which I added this 9, 11, 13 to get a longer list. Then there is the pop method which removes one element at the end. Okay, so it truncated my list from the end. A.pop2, the argument removes one element, but only removes the third element in this case, because 0, 1, 2. So the third element in this case, which was 5 of the list A, has now disappeared. Don't forget, you can always use the dir function on the object A, which is a list, to get a list of methods for that particular object. So you can see here that there are various methods. And again, as I pointed out last time in the question answer sessions, any method that starts with an underscore is not supposed to be used directly in your Python programs. Okay, it's a hidden method which is used only by Python internally. But everything else without the underscore, which means any of these methods, you are free to use. You can sort, for example, if you want to sort on some particular key, you want to sort your list alphabetically or numerically or reverse alphabetically or whatever, you can use the sort method. Okay, it's a built-in function, no modules need to be installed, and you can, as always, get help on this particular method by typing help a.sort. There are some very, very important implications of mutability. Okay, so I define list L as 1, 2, 3, 4, and I define M is equal to L. Okay, then what I did was L dot append 5. So which I meant was I added the element 5 at the end of my list L. So now what is the value of L? It's a list with elements 1, 2, 3, 4, 5. No problem. But if I do print M, it also became 1, 2, 3, 4, 5. Why is that? It's because when I did the statement M is equal to L, M was not a copy of L. M was an object that pointed to the object L. L and M are pointing to the same object. So when that object L mutated, whether you call it L or you call it M, those are just labels. You get the same mutated object. This is very important. Keep this in mind if you are working with lists. But suppose you want to make a copy. There's one array and you want to, or there's one list and you want to make a copy of that list. Then what you do is, if you change this, instead of M equal to L, you put a square bracket and colon. And what does this mean? What does the colon indicate? The colon indicates there's no number before the colon or after the colon. So the default starting point is the first element and the default ending point is the last element, because you haven't specified either. So it takes the entire list L and makes a copy of it and then assigns it to M. Now, if you append a fifth element and print L and M, they're different, because now remember L and M are different objects, right? Python has a module called copy for making copies of lists and so on. We are not going to go into that due to paucity of time and our single-minded focus to focus on astronomical data analysis. But I welcome you to refer to the standard library documentation if you're interested. The next data structure that we are going to look at are dictionaries. So what are dictionaries? So imagine a list as a collection of objects, object 0, object 1, object 2. First object has a location 0, second has a 1, and so on. Now, instead of giving the list as a list, a sequence of objects that are in a certain order, instead of doing that, suppose I rename location 0 with some string label as something, and location 1 I call something else. Earlier, you accessed objects at numbered locations A0, A1, and so on. Now you will access objects by specifying a location label A and some string. Let's see how this works in practice. So I define a dictionary D1 equal to, and I give a string A colon 3 and B colon 5. Now, if I print D1A and D1B, it prints 3 and 5. So here in this dictionary, A and B are called the keys of the dictionary, and 3 and 5 are called the corresponding values of the keys. So formally, a dictionary is nothing but a collection of key value pairs. So now we do a D1C is equal to 7 and D1A equal to 1. Now, since D1A has already exists, we defined it when we defined the dictionary in the first line. So D1A is already exists. So now its value is getting modified. Now, if I print D1, the value of A has changed to 1 because of the line here. The value of B has remained unchanged, and the value of C as 7 has gotten added to the dictionary. There are methods, just like a list has methods, a dictionary has methods. So you could do the keys is equal to d1.keys. The keys function will return the keys, is a method that operates on the object D1, on the dictionary D1, and stores it in the variable keys. You can print the keys, and that's a dict keys object, a special kind of object. Values can be stored in similarly by returning a list of values using the values method of the dictionary. D1.items will list all the tuples of key value pairs in our dictionary. So we've seen how to define a dictionary. The simplest way is to define it like this, which we did on the previous slide. Or you can do it like this. You define the keys and you define the values in the corresponding order and use a Python built-in function called zip, which will take one value from key and one value from values, the next value from key and next values from values, etc., and create the dict function, the dict built-in will create a dictionary which is similar to D1. Okay, there is a typo here. This should be D1. Similarly, D3, again, same as D1 and D2, you can create a dict like this. A is equal to 3, B is equal to 5, C is equal to 7. Or you can create a dict D4 with using a slightly different syntax by using tuples this time. Coming together as a list and then operated on by the dict function, which constructs the dictionary. You may find what is the use of dictionaries, particularly in the context of data analysis. So what you can do is, because you can label an array with a string, it becomes very easy. So suppose you want, if you create a dictionary called Z, which is the redshift, right? Now, if I give Z M31, then that will contain that value that will be returned will be the redshift of M31. So I don't care anymore whether M31 is the 7th line of my input data file or the 70th line. I don't care. As long as the label is correct, I'll be able to read in the redshift easily. Similarly, if you want the R magnitude of some other object, the luminosity distance for some other object, you simply read in all of these columns as dictionaries. And if you do that, you'll be able to access using easy to remember character strings. You'll be able to access all of the parameters relevant to that object. Of course, it's not very important when you're doing thousands of objects. But if you just want to compare object A with object B, it helps really to have access to that data in your Python program via an easy to remember label. Let us now look at loops. Okay, so the first loop that we will look at is the while loop. Again, those of you who are familiar with Fortran or C-like languages will have encountered the while loop. The idea behind the loop is that you have a command that needs to be executed multiple times, and you do that in a loop. And one of the most common loops is a while loop. A while loop basically, so long as a particular condition is satisfied, it keeps on running. So we have x equal to 0, and while x is less than 5, again, remember here, this also has a colon, and then an indented block. It simply prints the value of x, and x plus equal to 1 is a shorthand way of writing x is equal to x plus 1, which means replace the value of x by x plus 1. So it basically is a incrementation operator wherein the value of x gets incremented. So when it enters the while loop for the first time, the value of x is 0. So that's why when you do a print x, you get 0. And it gets augmented every time on the second line. So next time it becomes 1, 2, 3, 4, and so on. When it becomes 5, when x becomes 5, x is no longer less than 5, and the condition of the while loop is not satisfied, and that particular block, which is these two lines, are not executed. So you exit the while loop. Let's look at another while loop. X is equal to 1 while true. Okay. Now this seems a little dangerous, right? Because while true will always evaluate to true forever. So without the break statement, which comes a bit later, this loop is what is called as an infinite loop, a loop that will run forever. So we print x is equal to %d %x, which means it's going to print the value of x. And it asks the user, do you want to continue? If the choice is not equal to y, if you type in any character except y, there is something known as a break statement. So that break command actually tells Python to break out of this while loop. And this is the statement that will break the loop. Otherwise, keep on augmenting the value of x. Replace x by x plus 1, x plus equal to 1. So initially, so I've run it a few times below. Initially, x was 1. Do you want to continue? I said yes. Then the second time it asked me, I said yes. And the third time it asked me, I said no. And then it, of course, the break got executed. It broke out of the while loop and the program ended. Now let us look at the second loop that is commonly encountered in Python, and that is the for loop. Again, those of you who are familiar with other languages, Fortran calls this a do loop, for example, C calls it a for loop. These are widely available in all major programming languages. The difference between a while loop and a for loop is that a while loop is executed so long as a certain condition is satisfied. A for loop is executed for a fixed number of iterations. So now we've defined x is equal to a simple list with some values. For I in x, print I. So notice here the syntax of the for loop. For I in x, so for some dummy variable I, which lies in the object x, print the value of I. Now, what is x here? In the context of a for loop, the x becomes what is called as an iterable object. Actually, it's a list. But in this context, it behaves like an iterable object. And that iterable object returns or pulls out for every time the for loop is run, it returns the next value of itself. Okay. So for example, first time this for loop is run, I takes the value 5. The next time the for loop is run, it takes the value 6. The third time it's run, it takes the value 7, and so on. And that is why all of these things are getting, numbers are getting printed. This is a very, very powerful thing. So now because we said that that X here, or whatever in follows the in keyword, is something that can be, besides a list, can be other things. It can be a sequence, okay, which is this string hello. So for C in S, print C, it just every time it goes through the for loop, it takes the next element of that string hello and prints it all in one line up to the exclamation mark and stops. But people who are used to for loops or do loops where you specify a range of integers that you want to loop over, so numbers from X to Y in steps of Z, you want it back, sure, Python allows that. So there you have a function now called range, which returns an iterable object of the kind you expect. So what this range function does, it can take up to 3 arguments. The first argument is the starting point of your sequence. The second argument is up to which number, or up to a number which is less than which number do you want to go, and what is the step size. So again, those of you who are familiar with Fortran will see the parallels with your do loop, and similarly for the for loop in C, and we are printing the values. So initially it takes the value 2, then the value 5, because we are going in steps of 3, 8, 11, 14. Okay, it doesn't go beyond 14 because the next time it goes, it becomes 17, and that is obviously greater than 15, and it stops. Let's look at some what are called wicked for loops. Okay, so I have the variable A, which is a list, then the variable B, which is a sequence, and then I create a new zip object using the zip function, which is zip AB. And if I print the type of C, it gives me class zip, which means this is an object in the class zip. Don't worry about the details. But now if I do for I comma j in C, print I comma j, it will take the first element of A, it will take the first element of B and print it. Similar, then it will take the second element of A and second element of B and print it, and so on. Now, in a real life data analysis program, this could be very powerful, because what you may want to do is there are 2 columns that you want to process together in your data without touching any of the other columns. You could just zip them together like this and carry out a set of operation within a for loop using the zip function. So now let us look at another for loop. Now we've looked at strings as the iterable object. We've looked at lists as the iterable object. But there are some Python functions that can create an iterable object for you. So enumerate A, basically what it does is for I comma C in enumerate A, it basically prints out this string. The I plus 1 is used because Python is 0 indexed. Okay. Now class number 1 is age. So I'm now iterating over 2 variables, I and C, simultaneously. Character number 2 is E, character number 3 is L, and so on, right? And the enumerate function basically loops me through this process, right? So both I and C get augmented as you loop through over A. If you wanted to help, what does enumerate do exactly? How does it create an iterable object? And how does it return an enumerate object, and so on? If you type help enumerate, it will give you this. What does the print open bracket, close bracket do? Nothing. It just prints an empty line. I just did this so that the help was separated from the output of the code above. Just like you can break out of a while loop, you can break out of a for loop as well. Okay. So now look at this piece of code. For I in range 10,000, remember this range function will return for you now with just one argument, all numbers from 0 to 9999. 10,000 numbers will be returned. So the I in every iteration of the loop will take number values from 0, 1, 2, so on up to 9999. Okay. So if I percentage 2 is equal to 0, then obviously it's an even object, print is even and continue, which means go into the next loop of the for. If the condition is not satisfied, it will print it is odd. And if I is equal to 7, it will break, which means it will come out of the for loop, right? So now what it does is first time it's 0, of course, that is even, 1 is odd and so on. And it goes up to 7 and then breaks out. It doesn't go up to 8 because that it encounters I equal to 7. Now, if instead of I equal to 7, if I had said I equal to 8, I equal to 10 or any other even number, what would have happened? It would have gone here and every time it would have hit continue and gone on to the next iteration of the for. It would never ever have encountered this piece of code, right? It would have encountered the print statement. It would have printed the odd numbers, labeled the odd numbers correctly, but it would never ever have encountered this break, and it would print forever. So you have to be really careful while using breaks. Otherwise, your loops can go on running. Even for loops can go on running for a long time, and while loops can go on running forever. You can traverse dictionaries using for loops, and that's shown here. D is equal to a dictionary, which we have defined in one of the ways of defining a dictionary. And for key comma value in D dot items, print the key and the value. And we put in this arrow by hand as a string. In print A1 is 1, B is 2, C is 3, and D is 4. For key in D keys, print key and D key. So every time the value of the key will be different and you get the exact same output. Okay, so I will end with two very short remarks. We've looked at lists and dictionaries and so on. But in one of the earlier lectures, I had a question, can you recommend do's and don'ts of programming style in Python? And for that, I would recommend you to look at the style guide for Python code, which is called PEP 8. PEP stands for Python Enhancement Proposal. So if somebody wants to make an improvement in Python, they need to write up a Python enhancement proposal. And if that is accepted by the community, then that change is implemented. I urge you to study this PEP number 8 carefully. And I've given you the link to PEP 8 below. And the PEP 8 is very, very short. It says do this, don't do this, and so on. If you want a more expanded, more elaborate explanation behind the motivation for the suggestions in PEP 8, please look at that realpython.com link that I have provided. Python is fully Unicode UTF standard compliant. And what that means is you can use any language within the strings of the Python program. You can't write print in your language, but what you are printing can be written in any language of your choice. Automated translation application programming interface library for Python is available on this Google link that I have provided. You're welcome to take a look at that if you're interested in multilingual translations, transcriptions, and so on. But I just put in these few statements in various in English and various Indian languages, just to show you that it is quite easy for you to write programs that seek user input in a variety of languages, and can even print outputs in a variety of languages. Of course, Python being web friendly, you can use it to auto generate web pages in a variety of languages as well. So with that, I'll stop. I overshot by about 5 minutes, but I think that's okay. And we will take questions.
I want to a simple question. You are adding on the Python notebook, there is a slide at the last. How you are introducing that one? The slide column there is. So if I use the drop down box, I will get a different format slide duplicate and all these things. How you will get that? How you will getting that?
How am I making the slides?
Yeah, on the Jupyter notebook. So
Okay,
I
let
am
me let me just try to show you what I'm doing. Okay, so it's here. So it's are you able to see my screen? You're able to see my notebook. So I just go here. I basically have this slide type over here.
Yes, slide type.
So there I set slide, sub-slide, and so on. So
but how you are getting the slide type? That is
okay,
my
how are
question.
you getting that option? So 1 second. So you go to view, you go to cell toolbar, and you click on slide show. Are you able to see it?
Yes.
Yeah. If you do that, then this thing will appear. So against every cell of code, you get whether you want to make it into a slide or a sub slide. I mean, sub slide, slide, or markdown, not markdown, sorry, fragment, and so on. You can even put it to skip. Suppose you want to skip over some slides, you don't want to include them in your presentation, you can do that. And you can add some notes. So I haven't done all of those things, but it can be done.
Good evening, Yogesh sir.
Yeah.
I wanted to make a point about the UTF-8 strings. So Python is fully compatible with UTF-8 strings, but I don't think it is. It can use UTF-8 variables. So
that is correct. So it won't be able to use UTF-8 variables. The strings themselves can be used. But in the comments, for example, you could have comments in any language. There's no problem.
Yeah, and I wanted to ask, sir, can we volunteer as a teaching assistant or something? Because I have some experience in Python and I would like to volunteer.
Okay. So what I can request you is that we have the Moodle platform, which has been set up, and we expect that there will be a number of questions there. So I encourage you, if you feel confident, to answer as many questions as you can.
Okay.
And later on, when we are going to have the tutorial sessions, it may well happen that we'll need some help. So my Dr. Pritish Mishra is going to conduct these tutorial sessions. So he'll be able to contact you. So why don't you send an email to the NRC at Ayuta, saying that you're volunteering, and they'll send the email to us and figure out how you can help.
Very well, sir. I'll do that. Thank you.
Sir, good evening.
Go ahead.
Sir, in for loop slide,
yes,
the syntax is if for loop, there is a continue statement. After continue, there is a print statement that is shown in the slide. My question is, how different is continue and else statement in this slide, sir? Is there any relation?
Yeah. So can you repeat the question now that we are on the right slide?
Sir. Actually, here, if I percentage 2 is 0, then we are printing I is even, and then we are saying continue.
Yes.
Otherwise, it prints I as odd number. So
Yes.
my question is, if I percentage 2 equal to 0, print I is even, else print I is odd. Is it
Correct. That would also work. Okay, that would also work. But
okay?
what you can have, like you can have a if block without a corresponding else.
Okay. Okay.
Okay.
Yeah.
That is allowed. But if you have only an if block, that is also allowed, which means the if block, if the condition is satisfied, that if block is executed.
Okay.
If the condition is not satisfied, it jumps to the next line after the if block.
Okay. Yeah. Yeah.
So this
Thank
is,
you.
you're right. If you put in an else and in that else box, you should have, you put print I is odd. There's no problem.
Okay. Yeah. Sir, one more question. In lists slide, we have, for example, in the square bracket, we have 168 multiply by 3, which repeats this 168 pattern 3 times.
Correct.
So, I mean, is there a way I multiply this list by a constant? Like, for example, 168 is multiplied by, say, 2, then the list becomes 2, 12, and 16.
Yes. That you can't do with a list because that operator, the star operator or the multiplication operator, just reproduces the list. Okay. Yeah. So here we are. So if you do once, if you want to multiply 168 into 3, you can't do that with the star operator. Okay, you'll have, you could put it into the for loop, read each element, make sure it's converted into an integer, then multiply it by 3 and replace the list.
Okay. Okay. Thank you.
Do it that way.
Yeah.
Otherwise, so in
Yeah.
real life, you would need to do this with your data. Because you want to, let's say, multiply 2 arrays together or something like that, or multiply your array by a constant. In that case, you would need to use what are called the NumPy arrays. And those we will encounter in the 7th lecture. At that time, I'll explain to you how you can do that kind of operation on arrays.
Yeah. Thank you, sir.
Sir?
Yeah.
Sir, can we multiply 2 lists together?
No, you can't.
Okay.
It doesn't make any sense, no? What does multiplication of 2 strings mean? It will give you an error.
Okay.
So let me move on to answering the questions at the chat. If I specify input data type at first, can it be changed to another through the program? Yes. In fact, I had shown this in the first lecture. The typing is dynamic. So you can say A is equal to 1. And then on the next line, you can say A is equal to hello. There's no problem. A becomes hello, right? You can change the data type at any point in time. Sir, can you please explain how to define column of a data file? Okay. When I talk about reading and writing of data files, which I will do in one of the future lectures, I will explain that. Somebody asks about variable names and whether they're case sensitive. Yes, they are. Small a and capital A are different variables in Python. Could you please explain the string formatting methods again, if possible? Okay. Yes. Okay. So let's look at this. So the first way of string formatting, which you can see here, is %.2f. Percentage indicates that there is going to be a variable specification, a format specification to follow. Okay. So that's a code for format specification. 0.2 means after the decimal point, I need 2 values. If I do 0.3, it will print 3 values. Okay. F indicates that this is going to be a float. %s indicates here that whatever is there is a string. So you just take the string and print the string. And now in this case, it is only the ordering of the two variables, the two percentage sign, that tell you which variable gets printed where. So percentage gal name, comma, integral B magnitude, integrated B magnitude. So for the first percentage S, whatever the value of gal name is, which is going to be a string, which has this value, that will get printed. And for the integrated B magnitude, it will get printed as a floating point number with 2 decimals. So I've set it with only as a float with only 1 decimal point. So when it prints it, it will not print it as 13.6. It will add a 0 at the end because I want 2 decimal points after the 2 digits after the decimal point. So this is how the statement 1 would be. Statement 2 is, and 3 are the sort of Python's preferred way of doing things. Statement 1 is the C way of doing things. It is supported in Python because many people have moved to Python from C, so it's allowed. So here what we specify in now, instead of percentage signs, you have curly braces. And those curly braces, this 0 specifies that that's the first variable named in the format statement. So it tells you that it corresponds to gal name, right? And S tells you that it's a string, and 1 tells you that this is the second variable that I have, which means here you print in B magnitude. And again, the formatting is just 0.2f like we had in the previous case. It's just exactly like this, no difference. The third way is where you have a label for the variable. So here is a label called name, and the variable corresponding to that label is specified here. Okay. Again, there is a label for mag, and the variable corresponding to mag is specified here. So these are the 3 ways of doing it. I suggest you just try things out. Take the code, take the Jupyter notebook, run it, see what, make some changes and see what the corresponding changes in the output are. So what are ripple objects in Python? So I actually don't know the answer to that question. I can find out and tell you. And where can we use percent? Percent is, remember, is going to be used in a string where you want to substitute a value, some number or some other string or some float into the string. So typically it gets used when you want to print out some output or you want to read some input.
Yogesh, here I have the question. So regarding the percentage sign, you also use for the condition in the condition statement also. Let's say %2 is equal to 0, and you are writing it is even, right?
Yes.
So in that also use that percentage.
So that percentage has a completely different meaning because everything has meaning in context. That %2, if you will remember from the previous lecture, was the remainder operator. Okay. So if it's an even number, suppose I have an even number 6. If I do 6%2, the remainder is 0.
See.
And so on. So that's, you use the percentage operator to test whether the remainder is 0. If remainder is 0 by division by 2, it's an even number, otherwise odd.
So sometimes it is act like a operator that depend on where you are using, right?
It depends on the context. Yes. So there is something about pasting numerical data from one file to another. I will talk about how to copy data over from A to B in the correct way. We will do that mostly in the astronomy lectures. There I'll tell you. Yes. So can you explain the enumerate operation once? We are running a bit late. What I will do is this, that slide I will reproduce again in the next slide, in the next lecture. And I will go over it at the beginning. I think that will be an easier way of, because it will take a few minutes to explain, because when I explain the enumerate function, I have to explain what it returns, which is an enumerate object, which is a bit complicated to understand. So I'm going to skip that question now, but take it up next. What are the advantages of using dictionaries over lists and NumPy arrays? I thought I answered that. Let me try to see if I can jump back. Yeah. So look at this. Suppose you have read in a data file, okay? And there are many columns. There are many objects with redshifts and magnitudes and luminosity distance. Maybe 10 other columns are there. Now you want to compare the redshift of one object with another object, right? If you did it the old-fashioned Fortran or C way, you would have to first figure out that, okay, object A that I'm interested in is the 373rd object in my array, and something else is the 5719th object in my array, right? And then you'd be able to read its redshift. If you make a mistake in its position, you're gone, right? But if you have read all of these arrays into a dictionary and you know the name of the object. So here I've given M31, which is the Andromeda galaxy, and this is the Crab Nebula, and this is the nearest quasar, 3C273, the first quasar discovered. So these are very well-known objects, right? Astronomers, if you say M31 and 3C273, they don't say what you're talking about. So you will remember them easily. And then you will be able to find out the values corresponding to that by using a dictionary. Of course, you can have a NumPy based dictionary also. You can have dictionary support is there as well. So you don't have to give up the power of NumPy to work with dictionaries, or vice versa. You can combine the advantages of both. But compared to a simple list, the advantage is this, that there is no possibility of confusion, whether you're talking of the same object or not. If you want to multiply values of two columns, then how you will do that? Again, when I come to NumPy, you will see how easy it is. In NumPy, in one line, one can do that. But right now, if you want to multiply two columns, then use the zip function and put it into a for loop and multiply them together. That method exists, but it's going to be slow.